Hello guys, how are you today? So today I'll be explaining the mechanics course practice of chapter 1.1 until 1.7. So this is not the vectors chapter, this is one-dimensional motion. Let's start with the first question. What does it say? Which of the following statements are true about speed and velocity? Two bodies having the same speed necessarily have the same velocity. This is not always true. They could be having the same speed, because in the end speed is only a magnitude, not a direction. They could be having the same exact speed but going in opposite directions. That means they would not have the same velocity. Okay? Speedometers are devices that measure instantaneous velocity. No, they measure instantaneous speed. Instantaneous speed always equals the magnitude of instantaneous velocity. This is true especially and only in this case since we're talking about one-dimensional motion. And when it's moving in a straight line as well, in one direction. Now, instantaneous velocities, instantaneous speed in a specified direction, this is true. There has to be a direction, then you can say that this is velocity y. Velocity is a vector quantity, right? Whereas instantaneous speed is what? Whereas speed is what? It is a scalar quantity. So the vector quantity has a direction, and the magnitude, whereas the speed is only a magnitude. So we move on to the next one. Instantaneous speed can be lower than average speed in a given one-dimensional motion. Yes, this is true, because if we had the speed like this, for example, if we had a position time graph, and we had the speed going like this, then like this, then like this. At this specific point, if we took the instantaneous velocity, the instantaneous speed, my bad, it's gonna be less than the average speed, which is what? The total speed traveled, like the total speed of the journey. Okay, so that's question number 1 done. We'll move on to question number 2. What does it say? It says that the change in position described as the hiker moved through 10 kilometers is an example of a what? We know that the hiker moved through 10 kilometers. Perfect. Is there a direction to this 10 kilometers? No. If there is no direction, then we directly put it as a scalar quantity. Now, part B. The hiker moved through 10 kilometers due east. So he does move 10 kilometers, but in a specific direction, which is due east. So this is example of a vector quantity. We'll move on to question number 3. What does it say in question number 3? A person standing initially at the origin, which is point A, moves to point B and then back to point C as shown below. The scale is graduated in meters. Okay, so the scale is meters. They want the distance traveled by the person. He moves from A to B and then from B to C. C is at 9. So how much is the distance traveled from A to B? That's 15. And the distance traveled from 15 to 9, that is 6. So we add both distances, distance 1 plus distance 2, to get the total distance traveled by the person, which is what? Which is 21 meters. Now the total displacement is what? Is x final, which in this case is 9, minus x initial, which in this case is what? Which in this case is 0. So you need to subtract them. X final minus x initial equal displacement delta x. So 9 minus 0 equals 9. So the displacement is 9 meters. Perfect. Now we move on to the next question, which is question number 4. The diagram shows the path ABC followed by a girl walking her dog in the park for 0.60 hours. The diagram is not to scale. The average speed of the girl. What is the definition of average speed? Average speed is the distance covered over the time, whereas average velocity is the displacement covered, delta x, over the time. So what is, first of all, the distance covered by the girl? Because we're starting with average speed and its distance over time. What is the distance traveled by the girl? She goes from A, then to B, then to C. So she travels 1 plus 2.8 kilometers, which is how much? Which is 3.8 kilometers. Over what? Over the total time, which is 0.6. So put it on the calculator. And you will get approximately 6.3 kilometers. But because we're dealing with average speed and distance, there will be no direction because they are both what? They are both scalar quantities. So 6 kilometers per hour and it has no direction. Now, regarding the average velocity, it's the displacement over the time. Displacement can be calculated by taking x final and subtracting it from x initial, or in this case, they gave it to us to be 3 kilometers. So now we have 3 kilometers, the displacement over the time, 0.6, so it's 5 kilometers per hour. And because it is a vector quantity, velocity is a vector quantity because it's displacement, we will say she's moving from A to C. So she's moving in the northern direction. So she's directed due north. Perfect. We'll move on to question number 5. What does it say in question number 5? Consider below the position time graph of a descending drone. What do they need from us? The magnitude, not the value, the magnitude, because the magnitude, you always put it in absolute value, no matter what answer you get. So let's find the velocity. This is what, a meter second, so basically an xt graph, but they, instead of saying x, they labeled it s, and they told us that it's a position time graph. So let us find the slope, because we know that the slope in a position time graph is the velocity. So let's find the slope. Take any 2 points. For example, I'm taking this point over here. 6, 5, and 4, 10. Let me take these 2 points. So 6, 5, and 4, 10. And how do you find the slope? It's y minus y over x minus x. So it's going to be 5 minus 10 over 6 minus 4, which is what? Which is minus 2.5 meters per second. But do they need it? Do they need its value, or do they need its direction, or do they need only its magnitude? They need only its magnitude, so we'll put it in absolute value and we will get 2.5 meters per second. Perfect. Let's go on to question number 6. What does it say in question number 6? A car initially moving at 30 meters per second. So this is what? V initial. Decelerates to 5 meters per second. So this is what? V final. In how many seconds? In 3.8 seconds. This is what? This is the time. What do they need us to find? They need us to find the acceleration of the car. We know that acceleration is the change in velocity over time, so delta V over t. So it's going to be V final minus V initial over the time, which is 3.8. So 5 minus 30 over 3.8, that's going to be approximately minus 6.6 meters per second square. Perfect. Let's move on to question number 7. I think some of the questions are repeated, by the way. If we see something similar, we'll just skip. Okay. The xt graph shown below represents the motion of a toy car along a horizontal axis. Now, the time interval during which the toy car is at rest. When does the toy car come to rest if we're dealing with a position time graph? When we're dealing with a position time graph, the toy car will be at rest when the position is constant, meaning that the slope has to be 0. So at rest, the slope in xt graph is going to be equal to what? Is going to be equal to 0. So in this scenario, it's going to be over here. As you can see that the slope is 0. So what does it mean? It means it is at rest. Now another way you could think of it is that the position is constant. So you just see, where is the position constant? Here it's constant, because you see it's not changing. It's staying until here. It's staying at the same position for, I don't know, 3 seconds. So the time interval during which the toy car is at rest is from 0 seconds until 3 seconds. Now, part B. Now, the farthest point from the origin the toy car reaches is, very simply, where is the origin? The origin is this line over here. So when we're dealing with the farthest point from the origin, you're going to come from the origin here and you're going to see, okay, where is the farthest point? The farthest point for me is here. So at this point over here, what is this? This is the farthest distance from the origin, which is the line, right? The line with O. And so this is going to be what? This is going to be 10 meters. Perfect. So the answer over here is 10 meters. 10 meters. Now, the net displacement of the toy car, again, how did we say we would calculate displacement? Because we're in a position time graph, we're going to take x final and x initial, and we're going to subtract. So that is 10 minus what? Minus x initial, which is Is it 8? No, it's 6 minus 6, which will give me what? Which will give me 4 meters. So the net displacement is what it is, 4 meters. Now, part D, the total distance traveled by the car. Here you'll need to calculate it. So at first, the car is not moving at all. He's staying constant. It's staying in the same position. Then it moves from 6 meters all the way to what? To minus 4 meters. So what is the distance traveled in this over here? The distance traveled in this over here is 10 meters. Now, from minus 4 meters, it goes all the way to 0 meters. So that means the distance traveled over here is 4 meters. And then last but not least, from 0 meters, it travels all the way till 10 meters. So this is what? 10 meters as well. So what's the total distance traveled? It's 10 plus 4 plus 10, which is in total what? 24 meters. Now, part E. Now, the toy car is at the origin at instances what and what. Now, the origin for us is what? The origin for us is this line over here. Perfect. Now, what do they want from us? They want the times in where the car is at origin. Where is the car at origin? It's when it's here and here. So what are these two times? This time over here is 6 seconds, and this time over here is 11, 12, 13 seconds. So the two times at which the car is at the origin is 6 and 13 seconds. Now, we'll move on to the next question, which is question number 8. Question number 8, perfect. The graph below shows 3 runners completed a race, a 100-meter race. Which runner won the race? Definitely the person who covered all the distance but in the shortest time, who is Albert in this scenario. He covered the same distance as all of them, but in the shortest time. So Albert won the race. Which runner stopped for a rest? Definitely when we say he stopped for a rest, it means his position was constant. Now this is a position time graph, right? So when he was taking a rest, his position was constant. That means the slope became 0. And because of this, what happened? He took a rest, okay? Now, question number 9. The diagram below shows the trajectory of a skier. What's the net displacement of the skier from time 0 to time 3 minutes? Now, what's the net displacement? Very simply, it's x final minus x initial. So this is x initial. So what's x final in this scenario? It is 140 meters minus x initial, which is 0, which is equal to what? Which is equal to 140. So 140 meters, but it's directed in a specific direction. As you can see, he's traveling in this direction, which is what? Which is to the right. So he moved 140 meters to the right. Perfect. Let's move on now to question number 10. What does it say? It says the graph below represents the position time graph of a moving object. What is the average velocity of the object in the interval 1 second, 3 seconds? So how do you find the average velocity? Very simply, you're going to take the 2 points, 1 second and 3 seconds, which is over here. And you're going to find the slope, which is very simply 6 minus 1 over 3 minus 1. That's going to be 5 over 2, which is what? Which is 2.5 meters per second. So the average velocity of the object in this time interval is 2.5 meters per second. And it's positive because it's increasing. Now we move on to question number 11. A toy car is constrained to move along a straight track between points P and T. The displacement of the toy car and the distance covered by it are equal along which path? Along the path where they travel, in the same direction. So displacement and distance are only ever equal. So displacement is only ever equal to the distance traveled if and only if they're moving in a straight line in one direction. So in this case, it could be PQRT or TRQP, whichever works is a correct answer. So PQRT is a straight line and one direction, so this is the correct answer. Now they told us that the car moves PQRQ, right? The displacement of the car is he moves PQ, then QR, then RQ. What's the displacement of the car? It's position final minus position initial, x final minus x initial, which is 70 centimeters in this scenario. Now, however, the distance traveled is the total thing that they travel, which is 70, plus 110, plus another 110, but they moved it backwards, so plus 110 again. So we're gonna add everything, 110 plus 110 plus 70, which is what? Which is 290. So this is 70 and 290 centimeters. So perfect. That's question number 11. Let's move on to question number 12. Assume that a toy car is constrained to movement along this this track. Assume that the car can change its direction of motion very quickly due to the varying quality of the track. The toy car can move along different segments of the track at different speeds. The following data about the time necessary to cover each of the track segments has been collected. Drag and drop the correct answers to complete the sentences below. So what do they need? They need the average speed of the toy car as it moves along the path PQRTRQ. So what does this mean? We need to do the distance traveled over the time. So what is the distance traveled? The distance traveled in this scenario from PQ. First of all, it travels from PQ, then QR, then RT, then TR, then RQ. It travels all of these. So PQ, we can replace it by 10, plus QR, we can replace it by 20, plus RT, we can replace it by 40, plus TR, we can replace it by 40 again, and then RQ, we can replace it by 20. So add all of them together, it's going to be 10 plus 20 plus 40 plus 40 plus 20. We're going to get 130 over the total time traveled, which is what? Which is all of these times added together. So 5 plus 10 plus 18 plus 12 plus 10, which is 55. So the answer is supposed to be 130 over 55, which will give me an answer of 2.36 approximately meters per second. Now, the magnitude, not the direction. They want the magnitude of the average velocity of the toy car as it moves along this path. So what is the definition of average velocity? It's the displacement over the time. What is the displacement? It starts from P. So P is what? Is the starting point. And then it goes P, Q, R, T, R, Q, and it ends where? It ends at Q. This is the ending point. So we said that displacement is x final minus x initial. So it's going to be the distance in between Q and P, which is 10. So this is the displacement. 10 over the total time taken, which is what? Which is all of this added together. 5 plus 10 plus 18 plus 12 plus 10. And this is going to give us an answer which is approximately 0.18 meters per second. This is the magnitude. Now, in which second is the instantaneous speed the greatest? That means we need to find the instantaneous speed for all of them. Let us start by doing a couple of lines. So again, what's the definition of instantaneous speed? It's the distance traveled over the time at a specific instant. So from PQ, it's 10 over 5, which is what? Which is 2. QR, it's 20 over 10, which is 2 as well. 40 over 18 is how much? Is 2.22. 40 over 12 is 3.33. And then 20 over 10 is 2. So which one is the greatest instantaneous speed? It's this one, which is what? Which is TR. So the segment TR has the greatest instantaneous speed. Now, we move on to question number 13. What does it say? It says drag and drop the correct answers to rank the distances in the table below. If the distances are equal, give them the same rank. So, okay. Let us keep it here. We are dealing with distance. Which has a greater distance? Let's start with P, Q, R, T, R. P, Q, Q, R, R, T, T, R. So how much is the total? 80 plus 80 plus 120 plus 120. So how much is that going to be? It's going to be 400 centimeter moved. Now, PQR, what is it? It's 80 plus 80, which is 160 centimeters. PQP is 80 plus 80, which is also 160 centimeters. And then PQRTRQ, PQRTRQ, so that's going to be 80 plus 80 plus 120 plus 120 plus 80, which is what? Which is 480 centimeters. So if we were to rank them from the least to the most. These would be the same because they both have the same, so 3 and 3. And then second place goes to this one, and then first place goes to this one. So the order is what is 2, 3, 3, 1. Now, this is for the displacement. In my opinion, in the displacement, you only need to look at two values, or two things. The first and the last letter. In this case, it's PR. PR. In this case, it's also PR. In this place, it's PP. And in this place, it's PQ. Now, let us see. PR, PR, if I'm not mistaken. PR, PR, PP, and PQ. Now, from P to R, what's the distance? It's 100. What's the displacement? Sorry, it's 160 because it's x final minus x initial. From, again, same thing. PP is 0 because you start in the same place, you end in the same place, your displacement is 0. And then PQ is only 80. So if we were to label them from least to most, this would get 3, then 2, then 1, and 1 because they're both the same value. So 1, then 1, then 3, then 2. Now, what does it say? The speed at which the train can move along the track is 30 centimeters per second. Assume it can change the direction of motion very quickly. The engine of the train is turned on for 1 minute. So what's the time taken? The time taken is 1 minute. Right? They said that the speed at which the train can move along the track is 30 centimeters per second. What is the greatest displacement that the train can have on this track? So again, the greatest displacement possible, not distance, the greatest displacement possible is from P to T in this scenario, not in the second part, in part C. In this scenario, this is the greatest displacement possible because it's x final minus x initial. Now, Henry, what are they asking? They're asking for the greatest displacement it can move along the track. So we go back up and we see the greatest displacement possible, as we said, is from P to T. So we add everything together, 80 plus 80 plus 120, which is 280 centimeters. Now for part D. The greatest distance that the train can cover on this track over the course of 1 minute, greatest distance is very simply what? Is very simply the speed, which is 30 centimeters per second, times the time, which in seconds, 1 minute is 60 seconds. So it's 1,800 centimeters. Now we move on to question number 14, sorry. What does it say in question number 14? It says the following data about the position of a glider moving on an air track is collected by a sensor. The motion of the glider is uniform at which time interval? Let us find the velocity at each time interval. So from here to here, that's one time interval. Here to here, that's another. Let me zoom in so it's easier. Okay, from here to here, this is one time interval. From here to here, that's another. Let me change the color. Then, from here to here, this is another time interval. Then, from here to here, this is another, and so on and so forth. Now, let us find the speed of each of them in every time interval. The speed is very simply, the velocity very simply is the displacement over the time. So displacement is x final minus x initial. So 5 minus 2 is going to be 3. 3 over 1 is 3 meters per second. Then here, 8 minus 5 is 3. 2 minus 1 is what? 2 minus 1 is also 3. It's 1, but then it's 3 over 1, which is 3. 11 minus 8 is 3. 3 minus 2 is what? Is 1, so 3 over 1, which is 3 again. And then 4 minus 3 is 1. 15 minus 11 is 4, so here it becomes 4. 20 minus 15 is 5. 5 minus 4 is 1, so 5. 29 minus this is this, and 9. So as you can see, it goes from being constant, which is 3, then 3, then 3. Then what happens? Then it increases 4, 5, and 9. So at which time intervals was it uniform? It was from the time intervals 0 seconds to 3 seconds. Now, the speed of the glider in the interval identified in part A is what we found it already, which was 3 meters per second. Perfect. Let's move on to the next question, question number 15. Okay, the graph below shows the position of a robot constrained to move along a straight track. The average velocity over its 10 seconds of motion. What's average velocity? It's the displacement over the time. So he moved to where? He moved to minus 3. This is minus 3 meters. And then he started where? He started at 0 meters. So what's the displacement? Displacement is x final minus x initial, so minus 3 minus 0, which is minus 3 meters. Over the total time, which is 10, so you will get the average velocity to be minus 0.3 meters per second. Now, part B, the average speed of the robot over its 10 seconds. Now we need to calculate the distance traveled. So let us calculate from 0 to 6, that's 6 meters. Then here it doesn't travel any distance, it stays constant. Then from 6 to minus 3, this is 9 meters. So the total distance traveled was 9 plus 6, which is 15, over the total time, which is 10. And this will give us an average speed of 1.5 meters per second. Now identify the time intervals that correspond to the relative values of average speed and average velocity of the robot. Drag and drop the correct answers. So let us take each time interval by itself. Let us take the time interval, this one over here, and the time interval, this one over here, and this one over here, and let's find their average speed, and average velocity. We first start with this one. Average speed is the distance traveled, which is 6 over the time taken, which is 3, so it's going to be 2 meters per second. And average velocity is going to be what is the displacement, which is 6 minus 0, which is 6 over the time taken, which is 3, so it's also 2 meters per second. So here, from the time interval 0 to 3, it is the same. So average speed is equal to the average velocity. But if you go down, they actually gave us 2 different time intervals. They told us from 2 seconds to 6 seconds and from 1 second to 8 seconds. So let us do from 1 second, where's 1 second here, to 8 seconds. They want the value of the average speed and the average velocity. So in this scenario, the average speed is the distance traveled. So starting from 2, we went to 6. This is 4 meters traveled. Here they didn't travel anything. And then they went from 6 all the way to 3. That's 3 meters. So in total, 7 meters were traveled. Right? 7 meters over the time from 1 till 8, which is 7. So you're going to get 1 meter per second. Whereas for velocity, what is the total displacement? It's gonna be x final, which is 3 meters, x final is 3 meters, yeah. X final over here, which is 3 meters, and x initial over here, which is what? Which is 2 meters. So we're gonna get what? We're gonna get 1 over 7, which is way less than 1 meter per second. So definitely we can say that the average speed in this scenario is greater than the average velocity. Now, what's the next scenario? 2 seconds, 6 seconds. So let's take 2 seconds and 6 seconds from here to here. Now what happens? We need to calculate the average speed and the average velocity. Average speed is the distance traveled, which is from 6 and 4. This is 2 meters over the total time, which is 4. So it's 1 over 2 meters per second. And then the average velocity is what? It's the displacement over the time. So what's the displacement? X final, which is here 6 meters, and x initial, which is here, which is 4. So it's also 2 meters as well over the total time, which is 4. So in this scenario, the average speed is equal to what? Is equal to the average velocity. Now that leaves that average velocity is greater than average speed. It never happened in any of these. Perfect. Let's move on to question number 16. What does it say? A simplified assumption used to analyze complex situations is known as a model. This is for memorization. The location of an object on an axis at any instant with respect to the origin. There is something we're comparing it to. So its distance compared to the origin, or its location compared to the origin. This is known as what? This is known as a position. Move on to question number 18. Average velocity is the displacement over the time. Position is the location with respect to origin. Average speed is the distance over the time, and the model is a simplified assumption. I think we dealt with this before, no? Yeah, we did deal with this. This one came the same. If you guys remember, it was 0 seconds, 3 seconds, so I'm not going to repeat it. This was 10 meters. This was 4 meters. This was 24 meters, and this was 6 seconds, 13 seconds. It came exactly the same. We move on to question number 20. What does it say in question number 20? The xt graph shown below represents the motion of a particle moving along a horizontal axis. Choose the correct answers to complete the sentences below. The net displacement of the particle over the course of 30 seconds. What is net displacement? It's x final minus x initial. This is x final over here, which is 4. You guys should know how to read the scales. And this is x initial, which is 0. So what is the net displacement? It's x final minus x initial, which in this scenario is 4. So 4 meters. We'll move on to part 2, the total distance traveled by the particle over the course of the 30 seconds. Now we need to calculate the total distance traveled. From here to here, there was a 20-meter travel. Then from here to here, there was also another 20 meters traveled. Now, from here to here, there was 4 meters traveled. And from here to here, there was also 4 meters traveled. And then last but not least, oh, sorry, no, not 4 meters traveled. 8 meters traveled, my bad. So there was 8 meters traveled here and 8 meters traveled here. And then last but not least, there was 4 meters traveled here. So let us add them all. 20 plus 20 plus 8 plus 8 plus 4. It will give us a total answer of what? Of 60 meters. Now, part B. The average velocity of the particle in the time interval 0 seconds, 14 seconds to 2 decimal places. So we have what? We have the displacement and we need to find the average velocity. So it's going to be what? It's going to be 4. Actually, wait. Sorry, my bad. Ooh, I did not read. Guys, you should read in the exam. The average velocity of the particle in the time interval 0 seconds, 14 seconds. So you go to 0 seconds here and then you go to 14. This is 10, 11, 12, 13. No. So let's say that's 15. And 14 is over here. Let's say from here to here, this is what this is from 0 to 14 seconds. Now, what's the total distance traveled? From here to here, this is 20. From here to here, this is 20 as well. And from here to here, this is 8. So the total distance traveled here is what is 48. Now, we do not need the distance though, but we got it because we need it for the second part. But what do they need? They need the displacement because we're dealing with what? We're dealing with average velocity. So this is the distance. And the displacement, delta x, is what? Is x final, which is 8 minus x, minus 8, minus x initial, which is what? Which is 0. So what is the net displacement or the displacement in this scenario? It is minus 8. Okay, so let us find the average speed. Average speed is what is the distance over the time? 48 over 14. What do I get? I get approximately 3.43. And then the average velocity, what do? I take the displacement, which is minus 8, and I put it over the time, which is 14. So minus 8 over 14. And we will get approximately minus 0.57. Perfect. So this is minus 0.57 and 3.43. We'll move on to question number 21. Question number 21, very, very, very important. The xt graph shown below represents the motion of a particle moving along a horizontal axis. They want at moment of time, when the particle is instantaneously at rest. When it's at rest, that means the slope is 0 or the position is constant, and this is the case only at this time, which is 5 seconds. Now, at time equals 11. So we're going to go time equals 11. They want the instantaneous velocity and the instantaneous speed. Now, at time equals 11. Where is 11? 10, 11. Here. We're going to draw a tangent and choose 2 lines from this tangent. Now, please, my tangent is not going to be the best. My bad. So let's try again. Let me make the line thicker. Here we go. So now we have what? We have these 2 points. The first point is over here, which is what? Which is at time. This is 10, 9, 8. At time 8. And what's the position? The position is 16. And then we have another point, which is this point over here. What do we get? We have it at time 10, 11, 12, 13. And what position is it? It is in the position of minus 12, if I'm not mistaken. So if we were to do it, what would we get? We would get 16 minus 12 over 8 minus 13. So we're going to get approximately what? we're gonna get approximately minus 5.6 meters per second. So rounded, you're gonna get approximately minus 6 meters per second. Now, because we took the tangent, the instantaneous velocity of the particle of the tangent, okay, is the slope. But what also the instantaneous speed of the particle is the absolute value of the slope. So you're going to take the value of the slope, which is in this case minus 6, and put it in absolute value to get the value of the instantaneous speed, which is what? Which is 6. Perfect. Now, in a 3-kilometer run, very, very, very nice question. So what does this question say? It says in a 3-kilometer run, okay, this is the total distance d. Sam covered the first 1.5 kilometers at the speed of this and the second at the speed of this. They want what the average speed of Sam to one decimal place. How do we get the average speed of Sam? Very simply, it's the distance over the time, but we don't have the time, so we need to find the time. Time is the same as the distance over the speed, s. So in this scenario, we can find the time by doing the distance traveled over the speed. So 1.5 over 0.6 and 1.5 over 0.8. 1.5 over 0.6, that is 2.5. Plus 1.5 over 0.8, that is 1.875. Now 1.875 plus 2.5, this is in total 4.375. So the total time is 4.375, and we have the total distance as well, which is 3. So the average speed is 3 kilometers over 4.375 hours. And we will get an approximate value of what? Of 0.7 kilometers per hour. We'll move on to question number 23. A motorbike rider moves along a straight road due north for what would be a 300-kilometer trip. She covers 110 kilometers in 50 minutes. So look what happens. We have our motorbike rider. She starts at a 0 and she's supposed to complete a trip that is how much? 300 kilometers. Now, here she starts moving and she covers 110 kilometers in how much time? In 50 minutes. Perfect. So this we need to keep it in mind. She covered 110 kilometers in 50 minutes. Then she moves back how many kilometers? She moves back 50 kilometers. That means she lands at 60 kilometers from where she started. Perfect. Now this took her how much? This took her 20 minutes. Now after this, from this she continued her journey all the way until 300. So first of all, what's the distance? The total distance covered and traveled by the rider. So she went first of all for 110 kilometers. Then she went back 50 kilometers. Then she traveled where? She traveled from 60 kilometers all the way to 300, which is what? Which is 240 kilometers. Now we add everything together. 110 plus 50 plus 240. That's gonna be 400. Perfect. Now, what is the displacement? Displacement is x final minus x initial, so 300 minus 0, which is 300 kilometers. However, it's displacement, so there's a direction. And to which direction is she traveling? She's traveling due north, because it's written here behind the 110. So, 30 kilometers to the north. What's her average velocity? Very important question. Her average velocity is the displacement, which we know to be 300, over the total time traveled. She travels a total time 50 minutes. First, it took her 50 minutes to reach 110 kilometers. Then 20 minutes she went back. And then from 60 kilometers to 300 kilometers, it took her 170 kilometers. So all in all, it's 170 minutes. So all in all, it's 240 minutes. We needed an hour, so we'll divide by 60. So 300 over 240 divided by 60 is in the denominator, and we will get 75 kilometers per hour. To which direction? To the north. Perfect. So 400, 300 kilometers to the north, and 75 kilometers per hour to the north. Whew. Okay. Below is the position time graph of two toy trucks A and B moving in the same direction. We need to find the velocity of truck A, velocity of truck B, the meeting time, and the meeting position. So let's just choose any 2 points to find the velocity of truck A. For example, this point, which is 0, 2, and this point over here, which is 2, 4. Yeah, 2, 4. And then you will do 4 minus 2 over 2 minus 0, and you will get 1. So the slope or the speed or velocity of truck A is how much? Is 1. Now, for truck B, we're going to do the same thing. You will take this as 1, 0, 1, and this as 5, 2. And now you will do 5 minus 1 over 2 minus, oh, no, this is 2, 5, not 2, 5, my bad. So you're gonna do 5 minus 1 over 2 minus 0, and you're gonna get an answer of what? You're gonna get an answer of 2. So this is what? 1 meter per second, and that is what? That is 2 meters per second. Perfect. 1 meter per second, 2 meters per second. Now they want the meeting time and the meeting position. Where do they meet? At the intersection. So the meeting time is 1 second, and the meeting position is 3 meters. Such an easy question. Ooh, okay, question number 25. The remote control car is at momentarily rest. We know when we're dealing with an xt graph, when it's at rest, it means the slope is 0. So at this time, which is 0.5 seconds, it is momentarily at rest. Between 0.5 seconds and 2 seconds, the velocity of the remote control car. So let us find the velocity. We know velocity is this displacement over time. So from 2 till 0.5, from 0.5 over here seconds until 2 seconds, what is the total displacement? It is 0 over here, and over here it is approximately 2. And then, so now what are we gonna do? We're gonna be doing the displacement over the time. So what's the displacement? It's 0 minus 2, which is minus 2, over the time, which is 2 minus 0.5, which is what? Which is 1.5. So minus 2 over 1.5, this will give us an answer of minus 4 over 3. So this is the velocity. Oh no, they did not want it, but we got it to be negative. That means between time 0.5 second and 2 second, even though without solving you can see that it's decreasing, and because it's decreasing you can say that the velocity is negative. Now, the average velocity of the remote control car throughout its motion. How do you find the average velocity? It's very simply displacement over the time. So here it's 0, here it's 0.5, and the total time traveled is 2 seconds. So what's the displacement? The displacement is x final, which is 0, minus x initial, which is 0.5, over the total time, which is 2. So 0 minus 0.5 over 2. And this will give us an answer of what? Of minus 0.25. So minus 0.25 meters per second was the average velocity. Number 26. A particle P starts moving from the origin at time t0 along a directed straight line. Perfect. So let's draw. We have a directed straight line. It starts moving from the origin t0. Let's draw the origin t0 over here. Okay? Now, at time 1, 3 seconds, okay, the particle became at what time? At what position? At 9 meters. Then, at time 2, which is how many seconds? 8 seconds, it was found at minus 3 meters. And then finally, last but not least, at time 3, which is 12 seconds, it was found at 12 meters. They want the average speed of the particle. We know that the average speed is the total distance over the time traveled. So what's the total distance? The total distance is from 0 to 9. This is how much? This is 9 meters. Then he went from 9 to minus 3. How much is that? That is 12 meters. And then he went from what? He went from minus 3 until 12. So how much is that in total? That is 15 meters in total. Now, if you don't know how I'm doing them, I'm just doing 9 minus 0 is 9. And then minus 3 minus 9 is 12. Put it in absolute value. And then 12 minus 3 is 15, and put it in absolute value. And now what do we need to do? We need to add them all together. So it's going to be 9 meters plus 12 meters plus 15 meters, which is what? 36 meters over the total time, which is what? Which is 12. So what is the average speed? It's 3 meters per second. Now the magnitude of the average velocity of the particle, very simply, but between which time intervals? Between time 0 and time 3. So very simply, it's the displacement. What's the final position? 12 minus the initial position, which is 0, over what? Over the total time, which is 12. So you're going to get an answer of what? Of 1 meter per second squared. Perfect. Now, it doesn't matter if it's negative or positive. Why? Because they want what? They want the magnitude. Now, we'll move on to question number 27. Okay, this is a bit short, so what do they need from us? They told us a cyclist is traveling along a straight line OAB, and then back to A, coordinates of the 3 points being 0 meter, 20 meter, and blah, blah, blah. So they want us to find the displacement and distance from OA. OA, what's the displacement? X final minus X initial, 20. The distance traveled is 20. BA, what's the displacement? X final minus X initial, 20 minus 100, that's minus 80. But then the distance traveled is gonna be an absolute value, so it's 80. Now, OA, BA. This is how it traveled. Now, from O to A, that is what? That is 20 meters. From A to B, that's 80 meters, and from B to A, that's also 80 meters. So the total distance traveled would be 20 plus 80, which is what? Which is 180. Whereas the displacement is going to be X final minus X initial. So A minus O, which is what? Which is 20. So very simply, it's 20 minus 80, 20, and then 20, 80, and then 180. Here we go. Now we move on to question number 28. What does it say? It says the average velocity in the 20-second interval of the particle's motion. So they want what? The average velocity of the 20-second interval, which is what? Which is very simply the displacement over the time. So what's the displacement? It's X final minus X initial, 60 over 0 over the time, which is 20. 60 over 20 will give me 3 meters per second. Now the average speed in the 20-second interval of the particle's motion is, now there's a difference between average velocity and average speed. Average velocity, we use the displacement over the time, whereas now for the average speed, we're going to be using what? We're going to be using the distance over the time. So what's the total distance traveled? He travels first of all from 0 to minus 10. That is how much? That's 10 meters. And then he travels from minus 10 to 20, that's 30 meters. And then he travels from 20 to 60, that is 40 meters. So 10 plus 30 plus 40, which is in total 80 meters over the total time, which is 20. So that's 4 meters per second. Now, the highest average velocity is obtained in which time interval? Very simply, let's calculate the average velocity in between this time interval in blue, this time interval in pink, and this time interval in green. Now, let us calculate it. What is the average velocity? It's displacement over time. So for the blue one, what is it? It's going to be X final minus X initial, minus 10 minus 0, which is minus 10, over the total time, which is 5 seconds. So it's minus 2 meters per second. Now, the pink one is going to be 20 minus 10, that's 30, divided by the total time, which is 5. That's going to be 6 meters per second. And then last but not least, 60 minus 20, that is 40. And then 20 minus 10, that is also 10, so that's going to be 4 meters per second. So the highest average velocity is obtained in the time interval of 5 seconds and 10 seconds. Let's move on to question number 29. I love this question. It's a really, really nice question. It doesn't require too much thinking. It just requires being good at reading what is in front of you. So a sports car moving a constant speed of 20 meters per second passes by a stationary police officer. After 10 seconds, the police car follows the sports car at a constant speed v. The police car catches up with the sports car in 60 seconds. So let's draw the graph of what's happening. We first have what? A sports car moving at a constant speed of 20 meters per second. So let's say this is the sports car in blue. And then in pink, we have the police car. The police car, let's say, this point from the origin is the point at where the sports car and the police car meet each other, or are at the same position, right? So at this position, the police officer, he will see the speeding sports car. And he's like, okay, so he waits 10 seconds, because after 10 seconds, the police car follows up to the sports car until they reach the same position, right? So over here, this is the X graph, and over here, this is the T graph. Now, what did they say? They said that he travels at 20 meters per second. Let me change the color. That he travels at 20 meters per second, right? And that after 10 seconds, the police car starts to go at a constant speed v, and then he catches up with the sports car in 60 seconds. So in all of this, which is 60 seconds, he caught the sports car, but in total the time is how much? It is 70 seconds. Now what do they need us to find? First of all, they want us to find the distance traveled by the sports car. Of course, distance is equal to speed multiplied by what? Multiplied by the time. So the speed in this scenario is 20 times the time, which is 70, so it's 1,400 meter or 1.4 kilometer. Now, what is the speed of the police car during the pursuit? Of course, since they both meet at the same position, which is over here, what? 1,400. Okay, they both meet at the same position. That means that this slope, which we'll call it V, this slope S. Let's call it S. This slope S, which is the speed of the police car, multiplied by the total time taken, which is how much? How much did it take in order for it to catch up? 60 seconds. It took 60 seconds is equal to what? Is equal to the total distance, which is 1,400. So then S is equal to what? Is equal to approximately 23.3. Okay, so this is 1.4 kilometers and this is 23 meters per second. This is repeated. This one was how much? If I'm not mistaken. This was 4. This was 60. This was... Which question is this? 30? Let me try to remember because it came before. I'm not going to repeat it. 460 minus 0.57 and 3.42 or 3.43. Now, we'll go on to the last question. Oh no, this is even repeated as well. We already did this before, so this was 5 seconds minus 6 seconds and minus 6 meters per second and 6 meters per second. Let's submit and hopefully we do not have any mistakes. And perfect, thank God we don't have any mistakes. Thank you guys for watching. I hope you enjoyed and have a wonderful day.